Okay, as we start geometry, everything that we end up drawing, any pictures we always start with a point, and actually everything that we end up drawing is made up of an infinite number of points. So we're going to talk about points and what they are and kind of a brief description of them. There's not an exact definition of what it is, but there are some properties that we can go through. So, two things that we want to know about a point. It has no dimension, so it's not long or wide, and it doesn't occupy any space. So even if I put a point on here, I could come up with a ruler and I could, measure how wide this point is, and it would have some measurement. But that's just because I can't represent a point without making some kind of a drawing, and any drawing I make is going to have a dimension. So even though the point that I make can be measured, the point that it represents has no measurement. There's no width, no height, nothing like that. So all of our points are represented by a small dot, and we label all those points with a capital letter. So this could be point A. Okay, and then if I make another one, it needs a different capital letter. This could be point B. And they don't have to be sequential letters like that. I could say, okay, well, that's point Q. Doesn't matter which letters you choose. You always represent them with a capital letter. So points are the most basic figure in geometry. The next thing we get would be a line, and the line comes from having 2 points. Anytime we have 2 points, we can connect them with a unique line. The line is unique to, the points that are on it. There's actually an infinite number of points on this line, as many as I could squeeze on here, and then more, because since the points have no dimension, even points that I draw that appear to be touching aren't actually touching, because remember, they have no width. They're not taking up any space. So even though these points look like they're touching, if I were to blow this up, zoom way in, I could zoom in, and then these would be the 2 points I made, and I could again, squeeze 2 points on there. I could blow this up again, okay, to make it bigger like this. So there's no way that any 2 points will ever touch. The only time that 2 points will touch one another is if they happen to be the same point. So, if I say point B is here and point C is touching B, that means that C is actually B. No 2 points can ever touch because they're not taking up space. They just represent position. So they have to be in the same position in order to be touching. So lines only have one dimension, length. They only go in one direction. So they have a measurement that goes with them. When we make lines, we want to be sure to include these arrowheads on our representational line. That lets other people know that the line does not actually end here. It continues to go forever in the 2 dimensions. Lines are always straight. So when you draw a line, it has to be a straight line. If I say the word line, I'm talking about a straight line. If I want to talk about a line that has a curve to it, I will call it a curve or a curved line. So anytime the book says there is a line, it means it is a straight line. Lines are represented by a line with arrowheads at both ends. We label them. Let's see. Okay, coming up to that. So any 2 points can make a line. Each line has an infinite number of points, which I talked about. Lines are named after the points that form it. So if I've got this line below, I can pick any 2 letters that are on it and name it according to those 2 letters. And it doesn't matter which order the letters go in. So up here I could call it AB, because A and B are on the line. I call it A and C. Or really any 2 letters are on here. And then I just make sure that I put the symbol for a line above it. Okay, this is the symbol for a line. It looks just like a smaller representation of the line itself. So AB with a line above it, that represents this picture of the line that contains AB. Okay, or AC or BC, and it doesn't matter which order you put the letters in. So You know, I could also say BA with a line above it, and that's fine. Sometimes the book will put a cursive letter on top of the line, like letter M, and then it'll say it is line M. Okay, but then you have to say the word line M. Okay. Think about it, it's pretty unique that we can find 3 points that are all on this same line, because there are points everywhere that are not on the same line together. All these points, okay, aren't on that same line. They aren't on line AB. Okay, and even though there's an infinite number of points that are on this line, it's still pretty unique that we found 3 of them that happen to be on there. So since that's kind of unique, they get their own vocabulary. They're called collinear points. Okay, together, line, collinear, and those are just points that lie on the same line. If a line doesn't go on forever, so let's say it has 2 endpoints, then we call it a line segment. Line segments are named according to their endpoints. So if I want to talk about a segment that starts at V and goes to Q, I'm going to say VQ, and I'm going to put the line segment symbol above it. So that's a line without arrowheads. Again, the order doesn't matter. I could also just call it QV with a line above it. But this time I can't pick any 2 letters, so I can't say AB, because that would be a different segment. That would be this green segment, which is not the same as VQ. So you always have to use the endpoint. If a line has 1 endpoint, okay, so if a line only has 1 endpoint and one side of it goes on forever, then it's called a ray. Okay, so it would look something like this. If I want to talk about this entire ray, it would start at point D, and it would go towards E, or I could say it starts at D and goes towards F, and that's exactly how I name it also. So I could name it DE. Okay, it looks just like a miniature representation of itself. It starts at D, so that's where my symbol starts, and it's pointing towards E. I could also say DF, and those would be the same rays. Now the order does matter, because if I were to say ED, that would not work, because that would be a ray that starts at E and points towards D, and in this case, that ray doesn't exist, because the line stops right at D. So the order does matter. The initial point, which is the point where it starts, so in this case D, has to be the first point in your name. I could say EF, but then again I'd be talking about a different ray. I'd be talking about this red ray, which would not be the same as DF or DE. So just to recap, AB, the segment, is the same as BA, the segment. AC, the line, is the same as CA, the line. But BA, the ray, is not the same as AB, the ray. They are pointing in opposite directions. If we have 2 rays that point in exactly opposite directions, but start at the exact same point, those are called opposite rays. So up here, I have an initial point of B pointing towards C, and I can have the same initial point at B point towards A, and those would be opposite rays. Together, opposite rays form a line. So BA, in conjunction with BC, forms line AC. Okay, that's another way to kind of check to make sure you have opposite rays. So we've talked about 1 point. We've talked about when we have 2 points, all the things we can make from that. If you have 3 points and they're non-collinear, which means they are not all contained on the same line, okay, they can form a plane. So if you think of your computer screen right now as a flat surface with no depth, these 3 points, so A, B, C, could define that plane. Okay, another thing you want to know about planes is they go on forever. So if your computer screen were to extend forever that way, that way, okay, that way, kind of every direction that it can, it's just not coming out from the screen, it's not going into the screen. There's no thickness. So think of a sheet of paper, an endless sheet of paper that would slice straight through the earth. You know, it's like a giant knife cutting through the earth. That'd be a plane. Has no thickness. It's usually drawn as a quadrilateral. Okay, it's pretty much impossible for us to draw something that goes on forever. So we have a representation here. You know, we draw a shape, put some points on it, and then we name it plane, and then 3 of the non-collinear points that are on there. Sometimes your book will put a capital letter up in the corner, and they'll call it plane D. Just make sure that if you do that, there's no point near D to get it confused, because capital letters also represent points. Let's see. So 2 points are always collinear and coplanar. If I have 2 points, I can make a line with them. Okay, and they'll always be on the same plane because they only have 1 dimension. Planes have 2, so that means they're going to be contained on the plane together. 3 points might be collinear. Okay, here's another point in addition to my 2 that is not on the same line. So in that case, they're not collinear. However, they could be. I could put a 3rd point up here, so they could be collinear, but not always. They are always coplanar because these 3 points here would form a plane. These 3 points, the collinear ones, are still coplanar. They're on a line, and of course the line is always coplanar. 4 points may be collinear, they may be coplanar, but not always. All these things that we've talked about so far can interact with each other. So their interactions, if they end up touching, that's called an intersection. So 2 geometric figures are going to intersect when they have at least 1 point in common. If they never share a point, then they don't intersect. So if we talk about two lines intersecting, they're either intersect or not. They can intersect in 1 point. Okay, if I have 2 lines that cross, here's the point they intersect. They can be parallel, which means they never intersect. Another way that they can have no intersection is if they're skew, which is kind of hard for me to demonstrate on the computer, but think of if there was a line or a piece of string that was going through your monitor, right here, it's coming out of your monitor, okay, in a straight line, and this line would not touch that string, ever. That is an example of skew lines. They can also have infinite points in common, and that is if they happen to be the same line. So if I have line AB, and then I tell you about line CD, CD contains line AB, they're the same line, and they will share every point. If we have a line and a plane in common, okay, so again, the computer screen is your plane. This line would intersect it everywhere because it exists on the plane. The string that I talked about earlier, that would intersect it in 1 point, okay, the point that it kind of cuts through your computer screen. And then, of course, you could have no intersection if there's a string that's, you know, parallel to the plane. So it'd be running maybe 2 inches in front of your computer screen. If you have 2 planes, try to draw this. Okay, imagine that as 1 plane, and then you've got another plane that's sitting a little flatter. Okay, so it's coming across like this. Okay, that's behind the top there. these, you can kind of see the intersection here. Okay, right where this plane is cutting through the other one, that would be their intersection. And if you notice, it's a line. Two planes will always intersect in a line if they intersect. You could have parallel planes, you know, so if you have this plane and this plane is running parallel to it, they will never intersect. Or you can have planes that are coplanar, so they're sitting on top of one another. Okay, so if I have another plane that's sitting right on top of that red one, they'll have an infinite number of points. Every point that's on that plane will be on the other plane also. Here's the homework that I assigned for this first day. Again, there's a minimum requirement. That's what I checked. If you want a little more practice, you can do the extra.